So we obviously don't want to open our locks by pressing obscure buttons on our keyboard. There's a couple different ways to set this up in terms of how we want to actually change each dial. One, we can set it up with widgets. Others, we can click the actual dials themselves. We're going to do it with widgets. So what we want to do is come into the BP lock, and we want to add a camera to it. So when we go into the lock view, we can have a set view on the lock exactly how we want it. So what we're going to do is add a camera, and we can just position this how we want it, bring it back a bit. I'm going to change the field of view from 90 to 45 so we get something a little tighter. And I'm just going to put this at 0, maybe 15, might be a little too far. We want a real nice close-up on it, and maybe something like -5 because the pivot point here is at the top. Next, we also need to be able to interact with the lock. So just so you don't have to have the trouble of trying to click on this tiny little lock here, we can add a box collision to it. We don't want a child of the camera. I'm going to center it on the lock, however. And for each lock in the world, we might want to set these boxes to different sizes so we can cover up entire doors or chests, etc. So we're going to need variables to decide the size of these boxes. So we're going to create variables for those. And one will be called box position. That's going to be we do want it editable, and we want it as a vector. And then we want to make another one called box extent. This is also a vector, and it will be editable. I'm going to make the box extent default value to 32 on all axes. And in the construction script, we're going to get the box, set the extent to our variable. Now if we go into our scene, we can see we have this box here, and if we go to our details panel, we have this extent, and we can just drag these numbers here and it will update accordingly. We can do the same with the location, so we can just get the box and set relative location. And we'll get box position. Alright, so now that we have this set up, we can go ahead and use the box that we imported last episode. In meshes here, we have this box and box top. It's just a quick mesh to put the lock onto something. So I'll put it here in the light. I'm just going to drag that out and drag this out as well, excuse me. And just position it. I'm going to turn this down a bit. Okay, something like that's good, and we'll make sure this lines up. In most cases, you'd have this as an actor anyway, so be able to position it in the actor menu. Alright, that looks like what we want. Alright, perfect. Now we can put the lock onto our box here. If I remember correctly, the lock does not fit perfectly on this box thing, but I did make these fairly quick just as something to work with. Yes, it's definitely way too thick to be able to actually fit, but I'm just going to ignore that. I'm going to turn off snapping for a second so I can get it right on there. Cool. Now we have a lock on our chest. Now I want us to, when we try to interact with the chest, we go immediately into lock view, and that's what this box collision is for. So let's position this, not that way, we want it on the Z axis, not the Z, the Y, third time's the charm. And we'll just kind of get that right in the center there. Same with the Z as well. And then the extent. Okay. Something like that is good. So now whenever we try to interact with the box, it'll automatically interact with the lock because the box is not openable, I should say. So what we need to do is add our interaction interface to our BP lock right here. So we can go into class settings, implemented interface, we can add in BPI interaction. And we will create the interact event. Where are we? Is that the, okay. Our begin play, and under interfaces we have our interact, and we can right click and implement function. So when we interact with it, I want to be able to look through this camera so we can start messing with the dials. So what we're going to do is get the player controller, set view target with blend, and the new view target is going to be this camera. So we get the camera, and then we have to get owner and then plug that in. You can also just use self like this, and it'll automatically go to this camera, but I just like to select the camera. It'll give you the same result. Let's make the blend time 1 second, so it takes 1 second to go from our camera to this one, and that looks good. So we can test it out. So once we interact with our lock, which will hit this box, so if we hit this box at all, we'll set the new view target to the camera. So let's hit play, and let's interact. It is not working. Let's figure out why. Oh, I realized our issue. In our box collision here, it is not interacting with our line trace from our character, which I just opened here off camera. So when we call the line trace, it does it through our visibility trace channel. In our box, if we go down to our collision, it chooses to overlap the visibility trace channel. So we need to change our collision preset to custom, and then we need to block the trace channel for visibility. So it will register, then our interact hits it, and it should work now. So I'll press E on it, and there we go. And wow, flat textures look pretty bad this far up close, but everything works as it needs to. So we want to disable our character movement while we're in our lock state. So we can go to BP lock, and after we set the view target with blend, we can get our player character, and we are going to disable movement from our character movement. We also don't want to be able to look around, so we will get our player controller, and we are going to set ignore look input, and we will get our player controller ref, and we will set can open inventory to false. So it cannot open the inventory while we're checking the locks. Now once we're inside our lock view, we want to enable input so that if we hit the escape key, we can exit out of the lock view. So what we're going to do first is we're going to delay, and the amount of time we're going to delay is the same amount of time the blend time will take. So we only enable input once we're fully in. So I'm just do one. You can definitely set this to a variable if you want to. And then we will just enable input. And then we can just create the inputs for this. So I'll do input escape. And we're going to have a custom event for exiting the lock view. So let's create that before we do this. So custom event, exit lock view. We can just copy and paste this. So we want to set our view target back to our player. So we can delete this camera. And the view target will be our player character. We also want to disable input right as we do this. With our player controller being our player controller. We want to re-enable look input, so we will call reset look input, reset ignore look input. And we also want to be able to open the inventory, so we can get player controller, can open inventory. We want to set it, not get it, can open inventory to true. And we want to set our movement mode to walking. And if you remember, I've explained this before, this is the equivalent of re-enabling movement from this disable movement node right here, but we have to choose the mode, and that is walking. And now we'll be able to get in and out. So if escape is pressed, we will call exit lock view. Now, of course, if I were to hit escape in our game right now, it would just close the preview. So I'm also going to set this to the backspace key, just because escape won't work. And I will also set it to our action key, which is our E key. So if you were to press E again, you can get out of it. So now we can actually test going in. So I'm going to press E, and we're in. And I'm going to press the buttons to walk around, and I'm going to try to look around, also open my inventory, which doesn't work. And if I were to press E again, or backspace, we go back to our character, and we are in the same spot. Cool. So that works just as intended. So now we have to make the widgets for changing the dials. So we need to import the texture. It's just these arrows I made. So I have them right here in my resources folder, which will be in downloadable. I'm just gonna hit open. I will open this. Compression settings will be user interface, texture group, UI, and filter. We will keep this at default. Save. So let's close this, and we need to make a new widget. So user interface widget blueprint. I'm going to call this W arrow and open it up. We can replace the canvas panel with a size box. Right, we can't do it like that. We have to delete it and search. This will be desired on screen, so we know how big we're making it, and we will set it to 256 by 256. And we need to add a button, and this will be the arrow. So when we click on this arrow, it'll change the value of the dial. Let's make the image size 256 by 256. And it looks really weird right now, and that's because we are drawing it as a box when we need to be drawing it as an image, and that fixes it. Drawing it as a box, the sides and the middle stretch based off a margin with it, whereas an image won't do any stretching. All right, let's change the hovered and pressed. So I'm just going to copy the normal and paste it into hovered and pressed. And then hovered, we can just make it some kind of color, like blue maybe. And pressed, we can make it like a dark gray. All right, and we can compile and save that. So now in our lock dial, if we go to blueprints, actors, lock dial, we need to add these widgets. So let's add a widget component, and we will call this up arrow. And over here in widget class, we need to change it to arrow. The scale is going to be 0.001 on all axes. So it's real small. to rotate it 90 degrees on the Z. I'm going to change this to 1, so it's just a little bit above it, and 1 on the Y, so it's a little bit forward, just so it won't be clipped into the lock itself. And this one obviously needs to be rotated on the x-axis 180 degrees, so it looks like a up arrow. And then we can just duplicate this, and we'll call it down arrow. And on the Z, it'll be -1, and the rotation on the X will be 0. And then we can compile and save, and we can actually just go in here and see how the arrows look. If we hit E, we now have our arrows in front of our dials. So let's go back to the widget. So we can actually, oops, that is the wrong widget. So we can actually add some functionality. So let's go into the graph. And let's add a Boolean. We're going to call it add rotation, and it'll default to true. So basically, if this is true, it will add 1, and if it's false, it'll subtract 1. Not like should we add or should we do nothing. So if we press our button, so on pressed, we just have to ask if we are adding rotation or if we're subtracting it. So if we're adding it, then we need to rotate the dial in BP lock dial, but our arrow widget doesn't know of BP lock dial yet, so we need to add that. So let's add the variable lock dial ref for reference, and it'll be of type BP lock dial object reference. And now we actually need to set it. So let's make a function called initialize, and it'll have an input of our lock dial ref. So we can just set it like this and then drag this onto initialize, which will automatically create an input for us. And let's do the same with the add rotation. All right, so now we'll know for both. So now that we have a reference, we can drag off our lock dial reference, and then we can call the function, I'm blanking on what it's called, rotate dial, of course. Rotate dial. So we need a new event to rotate the dial backwards in case we want to subtract rotation. So if we go into BP lock dial, and we can just create a new one right now. So custom event rotate dial backwards, and we just need to ask the same thing if we can rotate. So I'm going to copy and paste that, and if it's true, we want to set can rotate to false, and then we want to call reverse from end on this timeline that we already created for rotating our dial, but this time we will play it in reverse. But no matter whether it plays or reverses, we are still looping from 0 to 36. And if we were going backwards, we want to rotate it -36 degrees so that it goes backwards. So I'm going to move this out of the way. And we are going to create another loop. So I'm just going to copy and paste that. Plug the alpha into alpha as well, but change the B to -36. Now we just have to decide which one of these two should we use, and we will decide that based off the direction that our timeline is going. If it's going forward, we want to rotate it 36 degrees forward. If it's going backwards, we want to rotate it -36 degrees. So whatever we're adding to the dial rotation, you'll get a select node. The direction will be the index, and if it's going forward and backwards. Now we need to add a little bit more logic, like we did right here, to make sure it always stays between 0 and 360. So off this false here, all it does is just skip to find number. But now we need to add another if statement, because we are going backwards this time, so we don't only have to check if it's greater than 360, but we have to check if it's less then 0. And we'll plug that in. And if it isn't, we can just continue to this find number. We don't have to do anything. But if it is, we need to set our dial rotation to a new number that stays inside the values of 0 to 360. And we'll do this with a map range clamped. The value is the dial rotation. And then if it's anywhere between the range 0 and negative 360, we just have to convert that to a range of 360 to 0. We will then set the relative rotation of the lock dial mesh at this number, so it resets to a number between 0 and 360. After that, we can go back into our find number function. All right, so now that we have the rotate dial backwards set up, we can go back into W arrow, and if we don't want to add rotation, as in we want to subtract rotation, we can now call rotate dial backwards. Set that to false. So let's go back to our lock itself, and let's get rid of these H, J, K, and L since we don't want to use them anymore, but we leave everything else. And we also want to get rid of this enable input because now that we're not using it for debugging, we no longer want the lock to have input. Great. So we need a new custom event called check every turn. And essentially what we're doing with this is checking every single time we change a number if the code is correct. Kind of what we were doing here, but we need to make it into an event now. And we will need a variable in our lock dial of the BP lock. So we'll create that, call it BP lock ref. Let's type BP lock. Oops, BP lock. Okay, had a little trouble typing that. And we want it to be editable and exposed on spawn. So that when we go back into our lock, if you remember, we spawn in our lock dials here in a for loop. So we can just right click the spawn actor and refresh it. We now have our BP lock ref show up right here. It's a little bit more efficient than setting it in an initialize function. So we can just get a self variable and plug that in. And the reason we've created this variable is because we want to call this check every turn event every time we turn the dial. So at the very end here, after it's all finished, and after we find the correct number, we just want to get our BP lock ref and call the check every turn. So every time we turn a dial, it'll check to see if the full code is correct. There is a warning here, and that's just because we have not compiled. Now it has registered that it exists, and we are good to go. Right, one more thing. It's important now, just because it's possible for our rotation to go into the negatives as well. Since we can rotate it backwards, we need to get an absolute of this right here. So it always converts it to a positive number. If we didn't do this, then we could end up inputting some code like 951 -6 rather than 6. By absoluting this, it'll always be converted to positive, so 951 6. So let's actually fix up this check every turn. We can just take this logic right here, and I'm just going to bring these down. Just a bit of organization real quick. I keep messing it up. And we no longer need to call the rotate dials because that will happen with our widgets when we click our widgets. We just want to check our code, and we don't have to worry about this delay either. So let's bring this over here. And I'm just remembering now that we don't actually need these right here, but I'm going to leave them for a debugging thing that we might do later. So you can delete these if you want, but you might have to put them back in if you want to create a debug. But this is all we have to do. Check every turn. We just have to check the code, and if it's true, we play the animation. But we still lastly need the ability to press the arrows, because when we go into our view right here, our mouse is gone and we cannot click anything. So go to BP lock, and when we interact and go actually into the lock view and just show the mouse cursor when we are in lock view. So check that, and then I'm going to copy it. So when we exit the lock view at the end here, we are going to hide the mouse cursor once again. So uncheck that. Target will be our player controller. We can put it here, or you can just get player controller. Do it like that. Either way, it should work. Now we just need to be able to click on the 3D widgets, which works just a little differently than clicking on it when it's actually in your UI. We need to add something called widget interaction to our BP lock here. We definitely could create a new trace channel for this if we wanted, but visibility will be fine for us for now. You can change the distance. You can imagine this as a line trace, how we're doing with the interaction, except the line trace is coming out of the point where you click. So this is the distance, 500 will be fine. And the interaction source, we want it to be mouse. And then we just have to set our left mouse button. So we will call input left mouse button. And on pressed, we get our widget interaction, and we call press pointer key to the left mouse button. And on released, we will do the same for release pointer key with left mouse button. And now we can test it out. We should be able to interact with 3D widgets by left clicking through this BP lock actor. So let's hit play. And I know we went through a lot since the last time we tested it. So if you remember, there's a box that we could set anywhere we want, and we set it to completely surround this chest. So if we want to interact with the chest at all, even if I hit over here, we will go into our lock view, and you can already see my mouse is interacting with these 3D widgets that are just placed in the world, creating a trace. So when I'm hovering over them, they turn blue. And then when I press the up button, absolutely nothing happens. This was unintentional. Let me figure out where we went wrong really quick, and I'll be right back. So as soon as I exited out, we got our runtime error access none trying to read property lock dial reference in our W error. So let's go into the function by clicking it here. And it doesn't know what we're talking about when we have this lock dial reference, despite this initialize function. And I know exactly why this is. We never called the initialize function anywhere. So the function exists, but it's never called. So what we need to do is go into our lock dial, where we have our two arrow widgets right here. And in the event graph, we have to go to the begin play. And before we set our random number, we're going to call those initialize functions. We have to do it for both. So let's get the up arrow. And sadly, we can't call functions just from this variable here. We have to get user widget object. And through this, we cast to our correct class. So cast to W arrow, or I should say cast to our widget. And we can convert that to a pure cast if we want. And then as W arrow, we can call the function initialize. So our lock dial ref, that'll be our self. So we can just get our self reference to self. And for our up arrow, we do want to add rotation. Now we can copy and paste all of this and we just need to set it for the down arrow as well. So I'm dragging this over the up arrow and it replaces it with down arrow. But we don't want to add rotation here, we want to subtract rotation. So I'm just going to uncheck this. And now it should be working. So let's hit play. Let's say E on our box. We're here. My mouse is still interacting with the widgets. And when I actually click on this, it should know that this is the lock dial we're talking about and we want to call add rotation. So it should add a rotation. Perfect. If I spam click, it still waits for it to get all the way to the all the way rotated so it doesn't get buggy at all. And as you can see in the top left where the debugging is happening, it's correctly looping and it's not going too far. And if we hit the down is not working. We have made another mistake. And when mistakes like this happen, I like to remind everyone that I like to keep the mistakes in the video because I want you to see that it's very easy to make mistakes and it's also good to learn how to find them. So we know that when we click the down arrow, it seems to jump to the one below it and then rotate up to the one above it. So something about this math is wrong. So let's go into our lock, or our lock dial, I should say. And we have a rotate dial backwards. All this should be correct. And we reverse our timeline. So it does reverse the rotation. That's actually working correctly. And I already see our issue. It's because we go from 0 to -36 when we need to go from -36 to 0. Let's see if that fixes our issue. Let's hit E. Let's go up. Up still works, and down works. And if you look in the lower left, or upper left, I'm sorry, our numbers are updating accordingly. Perfect. So just a small little fix there, something very easy to make the mistake. Happens to everybody. So let's make sure our check every turn is working. So right now, we already know it's checking every single time I change this if the code is correct. And every time it said no so far. But let's put it to the correct code and let's see if that registers and opens our lock. So let's change this to, I'm still forgetting our code, but I'm pretty sure it's 9516. And it has opened and we are still in here, but we can press E to get out. So I think what we want is to polish it up a bit. So first thing is I don't want those widgets showing when we are not out of here, you know, because it just kind of looks like some weird white dots on there. I don't like the look of that. So I only want the widgets to pop up when we're in the lock view. I also want us to exit the lock view if we have solved the puzzle. But all the mechanics so far work exactly as intended. So in our lock dial, let's take these arrows and let's go to visibility. And we're just going to turn visibility to false. So if you see, turns invisible and turns invisible. Great. So they won't be seen by default. In the lock, we want to set them to visible when we go into our lock view. So event interact, we do all of this, and after we show the mouse cursor, we want to show all of the widgets. So we can get our dials, and we need a for loop, or for each loop. And we can just get the two dials, so we'll do up arrow, I mean, not dials, the two widgets. So get up arrow and get down arrow. And we will just set the visibility to true for both of them. Okay, perfect. And then we want to turn these back off once we exit the view. So I'm going to copy these, and then here in our exit lock view, right here, at the end, we're just going to do the same thing, call a for loop, turn these off. So now if we hit play, and we get as close as we can see there's no widgets, and we hit E. They've turned on once we're here. If we hit E again to leave, they are gone. All right, that already looks a lot better. Lastly, I think I want it so if we solve our code, that we automatically exit the lock view. So let's go to BP lock, and here in check every turn, on off success of check code after we play animation, I'm just going to do a delay. I'm going to say just about 2 seconds will be fine, and then we can just call exit lock view. What you could also do is delay, say, another second or so, and then destroy the lock actor. So you can do destroy actor. You will also have to, since the dials are separate actors, you have to destroy those as well. So if you want to destroy them, you'll also have to go for each loop with the dials, and you would just call destroy actor like that. And this will destroy all the dials as well. So it's it. Compile and save. Play. And what we're going to do is test this out one last time. Let's get it to the correct code. 9, 5, 1, and 6. Waits 2 seconds. And then we leave, waits 1 second, and the lock is destroyed. And then we could interact with the chest per se if we had set anything up like that. So I know this was a quite a long episode, but now we have a perfectly functional lock that's should be customizable as long as you have the model, 3D model to support it. So thank you for watching, and I'll see you in the next one.